All right. So with that, I wanted to bring in our featured presenter for tonight. Trevor Higbee is the VP of Technology for ThriftBooks. We had some questions about DBT in our recent meetings, and so I reached out in the DBT community and met Trevor through the DBT Slack group. And he kindly offered to do a presentation about not just DBT, but as well the overall data platform transformation process that they went through at ThriftBooks. So really excited to have Trevor presenting tonight. Trevor, it is all you.
Roll
Awesome.
recording.
We are recording.
Great. So I get really excited about this topic, and I'm excited to speak with you guys about it today. Just a little bit about me. Can you guys see my screen?
Yes.
Yes, we can.
So I work for ThriftBooks. We sell used books online. We sell them through places like Amazon and eBay, but mostly we sell them through ThriftBooks.com. And we've been doing this. I've been at ThriftBooks for about 8 years. We buy from schools and libraries and thrift stores. We bring these books into one of our 7 facilities across the country. We bring them in like huge truckloads. And then we pull the books out. We take every single one, and there's a barcode usually on the back of a book, and we scan that barcode or we type in the ISBN. And then we have algorithms and software that tells us whether we want to keep that book and put it on the shelf, or whether we don't think we can sell it, so we recycle it. Once we put a book on the shelf, it obviously gets listed for sale, again, on ThriftBooks or on eBay or Amazon. And we wait for someone to buy it. That can take anywhere from, obviously, a couple hours to a couple months or a few years in some cases. But we've just really grown over the last year or the last 8 years since I've been with the company. We've grown from a very small company. When I started, there was one other developer, and she and I were just trying to like hack and make things work a lot of the time. And now we've got about 22 people in my organization. I've been a software engineer and a software manager, a director of software engineering, and now I run all the IT and technology for ThriftBooks. So it's been a lot of fun to kind of see that growth. Before I get started too much, the presentation is kind of split up into 3 pieces. So the first piece is our data journey, ThriftBooks data journey, and I'll stop after that. I think it's about 10 or 12 minutes, and pause for questions. And then I'm going to talk about how you'd build a data transformation pipeline without DBT. And then I'll stop at the end of that and answer any questions. And then the final portion, which is again about 10 or 12 minutes, is showing you some things in DBT. So in about May of 2019, I've started feeling like we just weren't scaling from a data perspective. All of our data was stored on-prem in SQL Server, and it was accessed by the business through our developers, which isn't good for a lot of reasons. Developers don't want to be doing that type of work, like analysis and building reports and stuff like that. But also, our developers work on a 2-week sprint. And 2-week sprints aren't great for like iterative analysis. And so it was really difficult for them to manage. People were kind of getting frustrated. We were using something called SSRS, which is SQL Server Reporting Services for all of our reporting, which is pretty developer centric. In addition to the kind of those organizational problems we had some poor performance. And I'll go into that in a little bit. We had no data warehouse, no data team, and really no data strategy to speak of, or at least one that we weren't driving. And so like in May 2019, what I saw was we had this explosion of data. We were using USPS and FedEx. We had our own data from our own fulfillment centers and our payment processor and Salesforce and Google Ads and PayPal and Apple Pay, and just so much data coming at us. And we were trying to put it into SQL Server. And our SQL Server on-prem is pretty powerful. A couple machines with 32 cores and terabytes of RAM in what's called an availability group. And it's got near-time asynchronous replication to a read-only replica. And on that read-only replica, we were doing scheduled jobs every night, every 15 minutes, every hour, whatever was needed, to build kind of the reporting and data infrastructure that we needed to for both our reporting and for our more kind of data science, ML type applications. And as I could kind of, I couldn't really articulate where the problem was, but I could just feel that it was getting bogged down and slow. And I could kind of feel people being like, you know what? This is kind of ridiculous. And nobody in the company knew how to fix it, including myself. So what I actually did is I just sent out a post on LinkedIn. This is literally from a year ago. And I basically said, I need help. I'm looking to answer really anything. I highlighted this last line here. I'm looking to answer a wide variety of questions from what a team looks like, to what BI front ends to use, to what data warehouse solutions work well. We really had no idea where to start, but I knew that it was a problem that had been solved before. So a couple people reached out to me and referred me to some friends of friends, which was really, really helpful, just to sit down and talk with someone who'd been through that before. And one of the first things they said was, you got to find a place to store your data. And so that was kind of stage one. How do we find a scalable data store? And then how do we kind of benchmark it against SQL Server, what we had? And I've got a couple examples here. Here's one. This is a view of our actual SQL Server instance in production. And it's a scheduled task that runs every night. And you can see the duration is about 1 hour. It's an aggregation of about 1.6 billion rows. And so this takes about an hour every night to run, and it builds something called inventory history, which takes all of our inventory that we've ever had and does all sorts of calculations on it. And what we found is when we took this, the same code essentially, and put it into Snowflake, it went down to 1 minute and 35 seconds. So from an hour to 1 minute 35 seconds. And this was kind of like the first kind of foray into Snowflake. We didn't really know anything about it, except it came with really good recommendations. And we were just kind of blown away. We really were. We were just like, wow, this is amazing. Let's get as much data in here as we can. Before we started getting data in there, we did a couple more tests. Here's one that we did that we documented. When on our website, we have tracking events. We track when people click or when they engage with different products on our site. And we have about 1 billion rows in tracking event. And then we have like a one-to-many relationship with tracking event info or tracking event detail. And it's about 5 billion rows there. And this just straight up doesn't run on our server in SQL Server. It took about 4 minutes on an extra small in Snowflake. And if you know a little bit about how Snowflake works, an extra small is about $2 an hour. And so that's just, it's just very, very little money to just really crunch through these massive amounts of data. So we got really, really excited about what we saw. But that's kind of like only the first step. Once you have a really fast platform to run your data through, then the problem is, how do you get all your data into your data store? We had terabytes of data in SQL Server, and we needed to get that up and reliably, probably 7 or 8 major databases with hundreds of tables, if not thousands of tables each, just tons and tons of data. And it was kind of daunting to think of like getting all of that up to Snowflake. So we looked at a couple.
Hey, Trevor.
Yeah, go ahead.
Real quick before you get off of that, you mentioned terabytes. Of somebody's asking, do you remember the warehouse size, total warehouse size?
On-prem?
Yeah.
I think, so we didn't have a data warehouse. We had OLTP, we didn't have a real data warehouse. What we had was an OLTP system that had a read-only replica. I think we were around 3 or 4 terabytes. Here's where we were.
Oh, sorry, he meant Snowflake. Oh, but then he said extra small later. So never mind. I think the questions are answered.
Okay, great. So yeah, trying to get data into Snowflake was kind of daunting to us, just because of the scope of it. So we went out and looked, and there's really 2 products that do a really good job at this. One of them is called Fivetran, and one of them is called Stitch. And both of them are software as a service, nothing to install. And essentially what you do is you provide your credentials to Salesforce or Google Analytics or Google Ads or Braintree or one of 100 different applications to Fivetran. And then Fivetran just sucks that data up at intervals, every 5 minutes to every 24 hours, however long you configure it for. And it pumps that data into Snowflake or SQL Server or Redshift or BigQuery or wherever you want to send it. But it's super, super point and click. I've got a couple examples here. Here we're setting up Salesforce to push to Snowflake. And we literally put in, on the setup tab, you put in your credentials for Salesforce. It connects, and then it says, great, we can, we've got all these tables you can load to Snowflake. Would you like to do that? So you just go in there and you click, 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 and you wait. You wait anywhere from 20 minutes to half an hour to a couple hours, and the schema actually just like straight up shows up in your data warehouse with all the tables that you selected. So it's pretty magical. And here's what it looks like for the scheduling UI. So it looks like for Salesforce, we have it running every 6 hours. Right, about every 6 hours. And you can see how long it takes to run, and you can see the extract and the process and the load. So extract and process, Fivetran does by itself. And then the loading, that's the only portion that takes any compute or any resources from the Snowflake side. So that's where they're loading it all into Snowflake. So you can see that it's actually super efficient. It batches pretty well. And we were able to do this on not just Salesforce, but on SQL Server. And it's pretty dang cool, because any DDL you do, if you add a column, or if you truncate a table, or if you add, if you rename a table or delete rows, whatever you do, Fivetran has techniques for making sure that that data doesn't get lost, that it gets transferred well. You never have to go in and like configure stuff. You really just set it and forget it. Again, I'm not a salesman for Fivetran. I think it does a really good job for what we need it to do. Stitch is another good one that I hear a lot about. I have perspectives on, we trialed both. I have perspectives on why we chose Fivetran, but they're both really just top-notch tools.
So Trevor, looks like there's a couple questions here.
Yeah.
The first one, does Fivetran first stage it in, for instance, S3, or does it load it, I guess, directly into Snowflake?
I imagine that it does some sort of staging into S3 or something similar, because I think that's what it's doing here. When it's extracting from Salesforce or from our on-prem instance of SQL Server, and it's storing it somewhere and doing some sort of processing. But that's all completely transparent to us. We don't know anything about it.
Got it. And the second one is maybe it's already answered here, but I'll ask it anyway.
Yeah.
Does Fivetran do full loads, or is it doing differentials?
It does it does an initial sync, and then it does differentials. So it's different a little bit for every. What it tries to do is find a primary key. So with all these external services that are reliable, that have reliable APIs behind them, it identifies a primary key for each of these, or an event date or something like that that's reliable, that they can use as a watermark to then add incrementally to the data set in your warehouse. With synchronizing from a database like SQL Server, they'll use the change data capture or the change tracking features in SQL Server to basically read your logs and replay those logs in your data warehouse. So it's actually pretty sophisticated. And that's one thing that Fivetran does a lot better than Stitch. With Stitch, for example, if you delete a row, it can't detect that you've deleted that row, because it's just looking at that watermark. And if a row is gone, it has nothing to synchronize. Whereas Fivetran is looking at your change tracking log, essentially, and replicating all those changes up to Snowflake.
Got it. Okay. And then a second one here. Did you choose upserts or append only through Fivetran, and then what factors led to your decision?
Yeah, so Fivetran doesn't, to my knowledge, it doesn't do append only. It just does upserts. It synchronizes everything all the time. And so that's one of the things we really like about it, because with a lot of other tools, you've got to like configure, are we going to do incrementals? Are we going to do full loads? Are we going to do incrementals throughout the week and then a full load over the weekend to make sure that we've captured all the incrementals? You've got to do all sorts of hokey stuff, not hokey. You have to think a lot about how you're going to implement it. With Fivetran, you literally connect it. It does an initial sync, which for us took actually like 3 weeks because we had so much data. And so you do an initial sync, and then once that initial sync is established, it's just reading off of those logs. And so whether you add or delete or update or remove or whatever you, DDL, whatever you do, it takes care of it because it's like when you set up replication in a regular database. That replication is basically just reading off of those logs and replaying those logs on your the replicated instance. That's essentially the technology that Fivetran is using to replicate to your data warehouse.
Okay. Looks like I've got a follow-up question here. So that means Fivetran stores state internally so that it knows to load incrementally over time as opposed to accidentally reloading the same data that it's already loaded in a previous run, correct?
Yes, it takes care of all that for you.
Okay.
Yep.
And then has replication placed a big burden on your OLTP?
Nope, because it's all log based. So change data capture or change tracking, and in SQL Server there's 2 different technologies, but either one is pretty lightweight and it's meant for replicating essentially. And so it's essentially as invasive as like logging. Like when you have logging and you do log shipping, it's essentially the same sort of invasiveness or tax on your system, which I think in most systems, there definitely is a tax for doing that. It's not super large. And what we found is that one of the really cool things is that as we started pushing data into Fivetran and really getting comfortable with it being in Snowflake, long term, and making sure that we had it backed up and proper controls around our data in the data warehouse, we were actually able to delete a ton of data in our OLTP system. And so we saw that the OLTP system performance actually got better because we were syncing stuff out of that OLTP system, even though there was a little bit of a tax with the Fivetran logging. But again, the logging on Fivetran is not high because it's not doing like a full scan of your tables to figure out what's changed,
Okay, got a couple more. We'll ask these 2 and then we'll move on because I know you want to get through the rest of the platform too. So is that, I guess the question is like kind of how much does it cost, if you don't mind sharing?
Yeah, I guess I think most software, they tailor it to how big you are, right? And so I don't really feel comfortable sharing that. I think, generally it can cost anywhere from $5,000 a year to like $200,000 a year. And I'll just say we're toward the low end of that.
Got it. Okay.
Maybe Trevor, if possible, like after you talk about all the other technologies, kind of what thing is like really costly that you kind of have to keep an eye on? I would assume Snowflake, but maybe some of these other tools add up too, versus which things are like, oh, it just does its job and we're not concerned about that because of all the value it adds to us. If you're able to summarize towards the end, that'd be useful.
Yeah, it's really interesting because Fivetran, the way I don't want to get too deep into the pricing model, but the Fivetran pricing model is such that the more you use it, the less it costs. So it's like it like scales logarithmically, right? And so they encourage you to like use as much as you can because then you get more like the cost per row goes down, but you negotiate a cost per row like every year. And so we're looking at how many rows. Like, so we bought a certain number of rows, a certain billion number of rows for the year. And I just monitor it and make sure that we look okay. But we have complete control over it because we have complete control over what data we bring in through Fivetran. And then Snowflake, the costs. shoot, I mean, you got to monitor it for sure. Because, but for those of you who don't know, Snowflake charges kind of charges storage separate from compute. So if you took a bunch of data and put like petabytes of data into Snowflake and then never touched it again, they would only charge you for the storage. And it's pretty cheap. It's like $20 a terabyte or $25 a terabyte or something like that. And then you've got the compute on top of that and completely separate. And the compute is basically anytime you're interacting with that data. And Snowflake can turn on and off in like 1 minute increments. So if you're not using it, it just shuts down at night and you're just not using it at night. And like I said, the smallest warehouse is an extra small. It's super beefy for kind of beginners. And it's about $2 an hour.
And then I guess just from your experience, the auto terminate and then spinning back up, has that worked pretty much as advertised for you all? Do you find there's like a certain size that always needs to be running to avoid like the cold start issues, or is it?
We haven't found a whole lot of cold start issues, actually.
Okay.
I think, I mean, it might take another second or two to start up the warehouse, but with as fast as Snowflake is, that's usually not a big deal.
Cool.
And you're usually, the load on Snowflake, the read-write patterns are a lot different, right? So you're not reading and writing in thousands per minute or thousands per second like you might on an OLTP system. It's like, if you want something out of this, you're getting like something big out of it. If you want to put something into it, you're putting something big into it. And so the cost of where a second or two might really matter on the OLTP system, it matters a lot less in something like Snowflake.
Sure.
At least for me, for our experience.
Cool. All right. Well, let's go ahead and move on, and as we get more into the platform here, and if we have any further, specific questions on technologies, we can, tackle those at the end too.
Yeah, I love it. I nerd out on all this stuff all day long, so it's kind of fun for me to just kind of chat with people who are interested. All right, so we looked at the scheduling UI. Again, it's just kind of as advertised. I'm not a salesperson, like for Salesforce or for Fivetran, but it really just is point and click and go, wait and go. So at this point, you've got a system where you've got SQL Server and you've got lots of other stuff, but I just put SQL Server here. And you're extracting with Fivetran and you're loading with Fivetran. So those of you who are familiar with ETL, extract, transform, and load, with the type of pipeline that we've built at ThriftBooks, we're following kind of like what's called an ELT sequence, or it's extract, load, and then transform. And so essentially what we do, and we'll go through this in detail, but we extract through Fivetran, we load into a schema in Snowflake. So here we're loading some tables, an inventory table and an order item table, into a raw database. And what we'll see in this presentation is that we transform this data that's kind of built for machines into a human readable format, so that so our BI folks and our business folks and our analyst folks can be really efficient in the way that they're querying, and so that these tables are really nice to work with. So yeah, that's Fivetran, extract, load, and then we'll look at transform here in just a minute, because that's what DBT does really well. The third thing is choosing a visualization tool, and there's a gazillion of these, and they're all good. We spent a long time looking at these because we knew it was really critical to kind of the buy-in from the business side and to kind of the success of the whole project. We wanted the project to look successful from day one, so it really made a difference to us that the BI tool worked in the way we wanted it to. We looked at Looker, at Chartio, at Power BI, at Periscope, which is now Sisense, and Tableau, and we also looked at Mode. And Mode is the one we ended up going with. And I guess one of the problems we have at ThriftBooks, again, like I said, is that our software engineers were kind of gatekeepers for our data. And what I really want to do is completely dismantle that and get our software engineers to push all of our data out, and for people in the business to be able to just consume that. And Mode was really, really good at that because you essentially write some SQL and you build a visualization. And developers are really good at that, and they're really fast at that. And so these next few slides just kind of give you a really brief overview of what Mode looks like. We could have a separate presentation on, what we liked about each one of these, and we can talk about that a little bit. But let me just show you what Mode looks like. So it's really simple. You write a query, you run it, you get a result set just like you would in your IDE for SQL, whatever you're using. So once you have that result set, and you can connect to on-prem, you can connect to cloud, which is really nice because there's kind of this transition point between are we on-prem or are we in the cloud, and people you want to get people onto the tool as quickly as possible. So you write this query, you get a result set, and then you've got that result set here, and you pivot it just like you would in Excel, and you create some sort of visualization just the way you want it. So here we're showing hourly sales by marketplace. So on Amazon and eBay and ThriftBooks, different, just hourly sales. And we're doing that just by, dragging these fields that ended up in the result set to our x-axis or y-axis, our group by or our color. And if we wanted to filter here, we could do that. And this would be done by an analyst or somebody who knows about the data really, really well. The analyst or your BI engineer would also take that visualization and add it to a dashboard. So you can see here that we've got a dashboard called Sales Real Time. You can scroll down on it. All these filters are really, really easy to create. You basically select which of these you want to be filters, and it's done. And so you can have a really long list or really short list of different visualizations. And then the killer feature for us on Mode was this. So as a consumer, as a regular business user, for example, if you're looking at a chart like this, you can click on this little button and you can view the query behind the visualization, and you can also pull down those query results. So that same result set that I just showed you that I queried, anybody in the business can export that. And for us, that might seem like a silly thing, but for us that was really important because people want to be able to see the data, download the data, maybe put it into Excel, play with it in different ways, but we still wanted it to be, like accessible in Excel for people, but not, we wanted to start training them on a different tool. The other cool thing is, so you can download the results, but you can also view the query. So if someone comes to me and says, hey, Trevor, this looks really weird, I don't know what's happening, I don't have to pull the repo, I don't have to have special tools, I don't really have to do anything. I click on this button, I view query, we look at it together, and I say, oh, well, the reason is because we have this sold price and this ship price, and we should be using this other field or this other value. So it's a really collaborative environment. And also, you can edit any of these at any time. So a lot of times what we'll do is I'll publish something and say, hey, this looks interesting. And then someone will take that, because they can see the SQL really easily. They'll take that and they'll build some other visualization on it and build some other visualization on it. And we've actually seen that be really successful, mostly with our CEO. He's pretty technical, and he loves, but he doesn't know the data really well. And so we just give him Mode, and he's like, oh, great. So he copies and pastes and kind of plays with stuff and is able to run visualizations and then share those out to the organization. It's been really, really super useful. So that's Mode essentially. And again, we could have a whole conversation about UI and visualization tools. Any questions from the crowd?
One from me first. On Mode, is there any way to have like a shared data model or something that you manage, so it's not or is it always a separate SQL statement per visualization or per notebook?
Really good question. So there's kind of two answers to that. One answer is that you have this thing right here. So this, I can't remember what it's called because we don't really use them, but you can take a join or a set of SQL and roll it up into an idea and select from that SQL instead of selecting from the individual tables.
Kind of like a Mode specific cube or extract or something like that, where it kind of stores it for you in some way. Okay.
Yeah. But actually, the way that we tackle this is on the Snowflake data design side. So all of our tables are designed in a way they're basically super long and super inclusive. And so what we end up doing is we have, so let's say we have, people want to know about orders, order items, shipments, customers, books and ISBNs, current inventory. There's like 12 things that people really are interested in most of the time. And so we have 12 what we call cubes, and essentially they're just massive tables with everything you could want, all the joins already pre-done. And those are done in Snowflake, and they're available in Snowflake. So what people do is they come into mode, and then they've just got like 12 tables that they can interact with. If they're interested in orders, they go to the orders cube. If they're interested in order items, they go to that one. If they're interested in accounts, they go to that one. So I know that like Looker has a lot more like features around kind of managing that that kind of code sprawl. I actually don't know a whole lot about that, but I know it's a problem that everyone's trying to solve, and that's kind of how we've solved it.
Great. We have some questions around, I think kind of on the Snowflake side, and actually kind of lines up well with how you said you guys hit it. So how does Snowflake scale for like high concurrency? Do the cost add up really quick? Does it start to perform poorly as you get, maybe your use case, you have a lot of people hitting this at once through mode? And then are you running in Azure, AWS, or something else?
Yeah, two really good questions. We're running in Azure mostly because we are like a legacy Microsoft shop. So we've been running for a long time on SQL Server, on C#, on .NET MVC, all the .NET Core, all of those technologies. So it just made sense. We have Active Directory, and so it just made sense to be in Azure. So that's where we are. And I guess I should say that Snowflake, under the hood, is using Azure or AWS or GC or Google, whatever you want it to use, essentially. What was the first question? I think I answered the second question, but not the first.
High concurrency on Snowflake. What have you seen? Anything you learned?
Yeah, so there's a couple things there. In addition to the size of the warehouse, and I may be speaking a little bit out of my my expertise, because we haven't really had that problem, although we are running into it a little bit now. In addition to the size of the warehouse, you can set up like a max cluster, or like a max kind of cluster, or max instances. So you can say that you want up to 4 instances of an extra small, and that helps to kind of mitigate the concurrency issues that you might see. But of course, it's 4 times as expensive too. What we've found, and the reason that I say we don't run into that a whole lot, and another reason that we really like Mode, is that Mode caches every result set. So, and it does it on a really, it's super, super fast. And so here we're pulling back 281,936 rows, or about 11 megabytes. Sometimes we'll pull up to 5 million rows. And when that gets pulled, it's cached by Mode, and then it never hits Snowflake again until someone wants to run it again, or until we've scheduled it. Some of these we scheduled to run every hour or every day or something like that. So that's probably why we haven't run into that issue. And we also use different warehouses to do different things. So if we're loading from, we don't just load from Fivetran, we load from Snowpipe as well. And we have like different customers. We have a different, we assign different warehouses essentially to different customers, so we can track the cost of the different types of activities that we're doing. So we know how much it costs to run Fivetran, because Fivetran is assigned a specific warehouse. We know how much it costs to run our Snowpipe instances, because it's assigned a separate warehouse. And so when you have separate warehouses like that, you really don't run into those concurrency issues.
Great. I think we covered the ones that were in the chat. So I'd say keep on rolling, and people can jump in with more in the future.
Awesome. So the last kind of stage, and this is where we kind of get into the real nuts and bolts, is you can go out and you can buy all of this stuff. If I were to do this again today, I think this would all cost, I mean, it would take the time to get the contracts approved by legal, essentially. You'd go out, you'd get Fivetran, you get Snowflake, you get Mode. If I were to walk into your company, I could do it in, and I'm not a consultant, I'm not going to walk into your company, but if I were to walk into your company, I could probably do it and get it done in like a month. But then the problem comes with all of your data, right? Like organizing your data in a way so it's available and beautiful and nice to interact with from a human standpoint can be really, really difficult. And so what we end up doing is we end up, like I said, extracting and loading into a raw schema or database. And then we run some transformations, and we'll talk about that with DBT. But essentially what you do is you take your inventory table and you normalize, you standardize the types, and you standardize the way that, that columns are named. And you might add some, you might join in some other information, and then you come up with an inventory table in your analytics database, which is a really nice, way for people to interact with it. And the same thing with order item. You might take your order item table from raw and you transform it into your analytics database into a really nice order item, but you might also pull from the inventory table. So it's not, you're not necessarily always pulling from raw, you're pulling from raw and other dependencies in analytics as well. And the goal with all of that is to create analytic tables for human consumption. All of our data, or most of our data, is generated by or for machines. That's what an OLTP system does. It just writes. And software is really hard to change sometimes. And so you start out with a column name in your OLTP system, and then you're like, shoot, I really wish we had named it something else because it's kind of a bad name. But you're not going to go through your whole application and change it in all of your application because it's just not worth doing. The software that runs it knows what that means and does its thing. And so you end up with a lot of kind of weirdness in your raw tables, and what you do is you make it available for human consumption in your analytics table, analytics tables. These analytics tables are also just a single source of truth. They're easy to query, easy to discover. When I say easy to discover, I mean I want someone to be able to look at one of my models, one of my tables in the analytics database, and scroll through it and be like, oh, cool. I didn't know we have revenue and tax information in the same table. I can probably do something with that. I'm sure you've all had that experience where as you start discovering the data, you start having more questions. And that's what I really want to try to spark as we're transforming the data into something that's human consumable. And then one of the real problems is this guy right here, maintainable and scalable. So this you can do on 5 tables, on 10 tables, on 20 tables. But you do it for 200 tables, and it really becomes a challenge to maintain and scale. And so the question is, how do you build a modern data transformation pipeline that does all of those things? Well, there's really 2 ways to do it. And there's obviously more, but I'm just saying you can roll your own. And when I say that, I don't say it like pejoratively. I think you can reasonably roll your own. You just have to know kind of what you're getting into when you do that. Or you can use a tool like DBT. And DBT has competitors. There's one called Terraform, not Terraform. Shoot, I'm blanking on the name right now, but there are competitors of DBT. And DBT is an open source. Let me just keep going down here. So if you roll your own, you'll need to solve a bunch of problems. And we're going to talk through all these problems here in our demo. But you've got to solve these problems. And these aren't insurmountable. These are not like rocket science problems, but they're things you'll have to spend time figuring out and thinking about and designing strategies around. And I guess what I'm here to say is that you don't need to do that. You can use a tool like DBT. If you go with DBT, all those problems are solved for you, plus all the problems that you haven't even thought of, that other people have thought of, that you won't even know you have until 3 years down the road, someone else has already solved that or is already solving it for you, because you have the backing of this great open source community and this great open source tool. DBT comes in 2 flavors. There's a command line, which is open source and completely free. That's what I'll be showing you today. That's what we use at ThriftBooks. And then they have a SaaS offering. It's called DBT Cloud. And it's pretty reasonable pricing. I think it's, don't quote me on this, I think it's like $50 a month or something like that per person, which when you look at the value that it provides, it's just really, really clear that it provides the value. I guess the reason we haven't got a DBT Cloud is because the command line version works really well for us, and we just haven't had the need. But if we had the need, then I'd have no problem taking a look at that SaaS offering. So I guess what I wanted to do now was show you how you would roll your own transformation pipeline, and then show you how you do that same transformation pipeline in dbt. I'm not going to go through, when I go through dbt, I'm not going to go through kind of the how. I'm going to go more through the what. What can it do? What is it able to do? What types of things does it? What types of problems does it solve? I can definitely go into how it does those things, later on if that's something some of you are willing to stick around for. But I guess before I go into the demo, does anybody have any other questions or things I can clarify?
We can go in the chat.
Yeah, I have one question.
Oh, go ahead.
Yeah, I think earlier you mentioned that you have to make a decision of whether to rent or buy a book, right? Or retain or buy a book, right? So is that decision based on coded rules, or do you use machine learning algorithms? If the latter, then what kind of algorithms are used?
Yeah, essentially we use statistics and machine learning to do it. 8 years ago when we started, we didn't call it machine learning, we just called it statistics. But essentially we operationalize supply and we operationalize demand. And if supply is higher than demand, then we keep fewer books on the shelf. If demand is higher than supply, then we try to keep as many as we can. And essentially that's kind of how we do it. But the real kind of secret sauce is, how do you operationalize supply? How do you operationalize demand? What metrics mean demand? And can you keep getting demand better and better and better? And what signals are you using to approximate demand? So that's how we do that.
Yeah, and I think that assumes things like, is that an old edition, or is that kind of book even being wanted? When you say demand, right? It's all these kind of things.
Yeah, so we sell so many books. We sell tens of millions of books every year. And so we have a lot of great data on what sells and what doesn't, and how long it takes to sell, and at what price point it sells, and on what platforms it sells. And so we can predict pretty clearly at this point. For 95% of our books, we can predict really well whether we're going to sell it, how much we need on hand, and things like that. Where it gets into trouble, and this is kind of off the topic a little bit, but I'd love to talk with you about it later, is like in COVID, right? So over the course of a couple weeks, everybody's at home, people are worried about money. Where else can you get 20 hours of entertainment for $4? ThriftBooks is a place where you can do that. And we just saw a huge spike in demand, and our algorithms didn't take that into account. Now they adjust, and they adjusted quickly, but I mean, it's it only goes so far, obviously, right?
Yeah, thanks.
And it looks like there's a question in here. And how do you distinguish the different kinds of data to be done in Snowpipe versus Fivetran?
So Fivetran has basically, if there's a connector for it, then we use Fivetran. And when I say connector, I just mean if Fivetran's set up to do it, we connect to it. So if it's a Google Ads or Analytics or Salesforce or SQL Server, great, we connect to it. But there's other data. For example, we've got a bunch of data in Elastic, and some of that data we want up in Snowplow. Well, it's already in JSON format in Elastic, and so we just take those JSON files, put them into Azure Blob, and then import them via Snowpipe. Or I'm trying to think of other. We used to do our tracking events, because the tracking events, I was showing that at the very beginning. We have these like 5 billion rows here. So there's tracking events and these tracking events here. 1 billion or 5 billion rows, that's over the course of like a few months. That's not a long period of time. There's just massive amounts of data going into those tables. They're not even tables. They're going into, I can't remember what they're going into, but they're not going into SQL Server. They're going into files, essentially. They're log files. And so they're not going into SQL Server anymore. And the volume of them is just like so huge that it would like triple our Fivetran budget. And so we decided, you know, that's just too big. We can write one script to take all this data and throw it into Snowflake, which isn't too big of an overhead to have that one script, but it, like, you know, reduces our Fivetran bill by a factor of 3. So that's another situation where we might use Snowpipe instead of Fivetran.
Got it. Okay. And then as we're going through DBT, there's an interest to see how you integrate DBT into your SDLC
Yep.
process, and have you figured out a good CI/CD pipeline with DBT tests?
Yep, we have.
So as we see that, and then there's another question here. From a data modeling perspective, how did you handle keeping history, since Fivetran does upserts around kind of, you know, OLTP attributes that are updated? So, you know, user history or those kind of things.
Okay. User history. I guess I'm not quite sure.
So like tracking history for, you know, your customer, and, you know, let's say I move, for example, and tracking that I used to live in, you know, Illinois, and now I live in California.
Yeah. So I think there's a couple things there. It depends on how you're storing your data. If you're storing the changes, then that's one thing. So some of the data that we store in like an append-only fashion. And then when we retrieve it, we reconstitute the latest rows, right? Or the most recent rows. So we never know, we don't have a like, hey, this is the most recent row. We just have like an append-only store. So when you're looking at historical data and you've got that append-only store, it's really easy because you can take any snapshot in time and look at that. But there's a couple features in Snowflake that also help you manage that. One of them, I think, is, I don't know if it's called snapshots or historical snapshots. You can turn on a feature where you can essentially look at what the table looked like at a certain point in time. And it's not even, it's like you do a select star from table where, and then there's some sort of keyword where some keyword equals date. And it just returns to you the table as it looked at that time, which is pretty remarkable. The other thing you can do in Snowflake is what's it called? Streams. Snowflake has a feature called Streams, which is essentially a change log every time that something is changed. So an update, an insert, a delete, all of those things are stored in a separate table. If you turn it on, it's all those events are stored in all those DML actions are stored in a separate table that you can use to say, oh, this was deleted at this point, this was added at this point, and reconstruct some history there.
Got it. I think got a couple people popped in that says it's called time travel.
Ah, okay, great.
So cool. I think we're good. Let's keep moving.
All right. So again, the goal of this demo and the goal of what we're going to be doing here is creating analytics tables for human consumption. Single source of truth is what we want. We want them to be easy to query and easy to discover. And the way we'll do that is I've got a schema here called TB Raw for ThriftBooks Raw, and we're going to create a schema called TB Analytics. And I'm going to show you how that would work if you weren't using DBT. And I'll keep this goal down here just so we can keep that in mind as we're kind of going through this. I don't need to drop anything. So I've got two tables here. One of them is called inventory, and the other one is called order items. Let me pull those up. Inventory and order item. So inventory is, again, a raw table, and it's a record of each book, each individual physical book on a shelf. And it's got a gen date, but the gen date isn't really a date, it's a timestamp, so that's something we probably want to fix. And then we've got this ID site X, and ID site X actually means ID warehouse, and ID warehouse 2020 means that it's a new book. So already we're seeing that there's like a ton of like nuance to this that our systems understand, but aren't really like super awesome for humans. So what we do is we end up writing a query like this, which just makes things a little bit easier for us. So we have an ID inventory, We have nice naming conventions. We have a timestamp. It's very clear what that is. We have a date, very clear what that is. And we have an ID warehouse instead of that ID site X. And then if we want to materialize that, it's pretty simple. And again, this is if you want to roll your own transformation pipeline. We've basically done it, right? We just created a schema called TB Analytics, and we created a table called inventory in that schema. And if we double click on that, and just click on the data, you can see that it's just materialized a view for us. So anybody from our BI tools can now have access to this really, really beautiful data, and we can schedule this to run once a night or every 10 minutes or whatever we want. But it gets more complicated, obviously. Oh yeah, so here's an example of just being able to really nicely. So now, because we've put this into the analytics database, we now have a gen date that we can group by. We used to have a gen timestamp, but we've casted it as a date here. And so that's just one extra kind of feature that we've introduced for our customers to be able to discover and query a lot easier. But then our customers come to us and say, hey, we really like your inventory table. We'd like something called book type. We'd like to know whether the book is new or used. So we say, great. We know that ID site X is kind of like an overloaded table. And we can create a nice field for them that gives them that. And then in your BI tool, you can create something like this, so where you have a gen date, and then you split out new and used, and now you can do a quantity, and you can visualize that over time with what your inventory looks like in new and used. So already we're creating value just by writing a pretty simple SQL statement and materializing that to an analytics kind of single source of truth. We're going to do the same thing with order item, and we just got two tables here. If you look at this, this looks okay, but I like to put underscores between my words in databases, and the table is called order item, and this is ID order item identifier, which is kind of a weird name. So I'm just going to make that a little bit easier for us to read. Just do some renaming here, and nothing really, and not much else. And so as soon as we do that, we see that we like it, and we can materialize it. Before we do that, someone comes to us and says, hey, Trevor, I really like this book type that you've got in inventory. I wonder if you can add that to the order item table so it's a lot easier for me to query. I have two options at this point. I can join in the inventory table, the raw inventory table, and do this case statement again. Or if I don't want to repeat myself, I can just bring in book type from inventory and interjoin that, and then materialize it. I know I'm going a little bit fast. I hope that's okay. I just kind of want to show the general principles here. So if we refresh our TB Analytics, now we've got inventory and order item. And order item has a really nice field in it called book type, which we stole from inventory. And it really helps us to have an easier query and discover things a little bit more easily. And then our analysts, our BI folks can do something like this, and they can look at new and used, not only new and used inventory, but new and used sales. And you can see that this is still a single source of truth. We don't have to go rummaging through all the different permutations of places where different developers have defined book type. It's in one place, and we can use it over and over and over again, and hopefully everybody's seeing the same thing. So the next question, which is what someone in the chat was asking, is how do we productionize this? And that's actually pretty simple too, and that's not something that DBT really takes care of, but we can talk about, I will talk about a little bit more. Essentially, you put it under source control. You run a git init on whatever folder this file is in. You push it to a remote. You add whatever policies you want so that you can have people review or approve before it merges into master. And then you automate pushing the script to a server, and then you run the script from the server on a schedule using the command line. So, I mean, all of this stuff can be done pretty easily using the basic tools in any CI/CD platform. All you're doing is running bash commands or running commands from the Windows console, copying things, or running like a CLI SQL client to run your scripts. So that's done. I mean, it's kind of nice. It's easy because you've just taken your raw tables that are kind of inscrutable and a little bit difficult to understand from a business perspective, and you've started making them very, very easy to understand. And you've made it maintainable because you've got it, source controlled, and all you got to do is push and create a pull request, and on the pull request it can automatically deploy, or it can sit there until it's ready to be scheduled for the night using a cron job or a Windows task or whatever you've got in your environment. So at this level, it's super, super easy, but you end up running into a lot of problems as you get from 2 tables to 3 to 5 to 10 to 20 to 200. I've not yet gotten to 2,000, but we're close to 200. And one of the problems you'll find is dependencies. So here I've got I'm pulling for this order item table. I'm pulling from my TB Analytics inventory, and that's a real problem if I do this, right? Because I'm going to generate this, and then it won't get incorporated into this until like the following day or the following run. And so it's really, really important to keep track of your dependencies. And on 2 tables, it's not a big deal, but on 200, it can get really, really hairy, and your dependencies are really going to kill you. And that's actually the core thing that DBT does, is manage your dependencies. If you don't use it for anything else, it manages dependencies really well and makes sure that everything runs in the right sequence. Another thing is environments. So what if I want to have a development environment that's called TB Analytics Trevor Higbee? Or what if I want to push it to QA? That can be a little bit different. It's not unsolvable, but you've got to change these schema names in here, and you've got to do some sort of maybe find and replace, or some variables or something to kind of get that working. So you have to find out a way of doing that. Problem 3 is regressions. You'll always have these on your team, obviously. But let's say I come in here, and I'm just going to do a really simple cross join. So this cross join is we're just joining this table on 2 rows, and we're essentially going to duplicate all the rows in each of our tables. And this is going to happen. You're gonna be creating your models, and Monday afternoon everything looks good. Tuesday morning you wake up and your finance folks are like, hey, everything is doubled, and when everything's doubled that someone has done a join incorrectly. It's usually not a really obvious cross join like this, but they've done a join incorrectly, like we've done here, and suddenly instead of 888 rows we have 1,776 rows. And so managing that type of change, especially when you get a lot more people into your data organization, is really, really challenging if you don't have a tool set up to help you. Monitoring performance over time is another thing. So if I want to, essentially what this is doing here is we're creating a table or a schema called run log and a table called run log. And for every table that we materialize, we're going to wrap it in this like logging framework thing. So we're going to generate a GUID and then insert into run log have a create start time event and then a create end event. And that's cool and all. It gives us the data we want, but it makes everything really, really kind of messy. When you've got all this stuff in between, you can't really see what's going on. You can see that it works fine though. We have we got to create start, create end, timestamp squids. Everything's you can figure out, you can monitor how long things are taking really, really easily. But again, it's something you have to invent and you have to monitor and all that type of stuff. As we scale, speed becomes an issue. So we already had some questions about incremental versus full loads. This is going to do a full load every time. If we've got tons of rows in inventory, we're looking at 1 billion rows maybe in inventory, this might take a while. And if inventory is just an append only, then you're not going to want to generate that every night. You're going to want to do an insert or maybe even an upsert. And so you want to do this, right? Let's see if I did that right. No, we don't want to drop this table. You want to do something like this, where it just inserts into inventory anything that's new, anything with the gen date is greater than the max gen date from this table. But then maybe the problem is with this, what if you don't want to do this on weekends? What if you want a full refresh on weekends? Or what if you've added a brand new column and you need to back populate all the data in the inventory table? This isn't going to do that. You've got to regenerate the whole table. So you end up like doing some hokey stuff to get that working. So that's another problem you will definitely run into. I think that we're down to the 6th problem. I think this might be the last one. Development takes so long. So if this takes an hour to generate, because it's got so many rows, as a developer, I'm going to be sitting there and I want to test my change, but I run it and I'm like, oh man, this is taking forever. I just added one little tiny field. I just wanted to make sure that the join works and that I'm not duplicating too much. I'm not duplicating fields. What you would do is you just say, oh, awesome. I'm just going to create a view out of it. And then you can create a view. And if we refresh, obviously, we've got a view there for ourselves. But you just want the view during development. And you want to go back to materializing the table in production. You don't want to keep that there. So you want to have some flexibility. But you end up kind of changing all sorts of stuff and looking at, you end up get diffing everything to see what have I changed that has to change for the product feature, and what am I changing just to make my system work. So you'll end up with that problem as well. And the good news, and the reason I'm kind of showing you this kind of from the ground up, is that I think it's a really good way of illustrating what problems dbt solves. So it solves all these problems and more. I guess before I go on, I'll stop and just kind of ask questions. We're going to go into dbt and kind of see the features that we use to solve all these problems.
So I think we had one question, but I think you answered it. It was just so when you refresh or reinstantiate and reloading the same table, right? And that came in early on. And so I think you added that recently as, you can add in, just do incremental loads based off of that, that date. So, yep. So I think we're good.
Cool. So I'm going to go ahead and drop all of that stuff so that we can redo it in dbt. So let's refresh. There we go. So now we're back to square one. We're with TV raw, and we're going to do the same. We're going to do that same workflow in dbt. And I've got it already up here for us. And the first things we're going to look at is how dbt handles dependencies. I said that's like the core thing that it does, and then how it handles environments. So like I said, I'm not going to go too much into how it's set up, but you can see I have an inventory model here that is my SQL for building the inventory table in my analytics schema, and then I have the order item table. And you'll also notice that I'm kind of using this weird syntax here. Trust me, I guess at this point, this is just a reference to our raw database inventory table. And the reason dbt uses this strange style, this is some Jinja templating. The reason it uses this is so it can build a dependency graph of the different SQL models that you've got. So it inspects all of these. It sees that, oh, we need this inventory table. And then it inspects it inspects order item and sees that, oh, we also need that inventory table that we just created. So I'll do inventory before I'll run order item. And you can see that these two SQL files are in my models folder over here. And I can just run dbt run, And dbt run will go through all my models and run them against my target, which I've set up in a configuration file. Oh goodness. So we may have some Postgres experts here. I am not one of those. Let me just restart the server here real quick. I understand on Postgres, I think it doesn't do, I've been working with Postgres for about 5 or 6 days now, just for kind of this demo. But I understand that Postgres doesn't do like pooling of connections. And so I think I keep running out of connections because they're not pooled. I'm not sure why it's not closing them or managing them well through dbeaver, but if someone knows, I'd be interested in kind of chatting afterward. While this guy's restarting, any other questions?
Nothing in the chat.
All right, we'll just wait. Wait a minute here.
This is a great example of part of a data engineer's job is sitting there waiting for databases and clusters to start up. Apparently Snowflake's really fast, but you know, Databricks is a bit slower as you're sitting there going, all right, 5 minutes,
and like,
what can we do?
Figuring out the intricacies of different, you know, database platforms too. Like I said, you know, Postgres is not my, it's not what I've spent a lot of time on, and it's just it's fun to learn, but it does take some time.
So while that's going on, going back to the machine learning thing, does your machine learning algorithms operate directly on the data in Snowflake, or is that, how does that work?
Yeah, it does. So we take the data in Snowflake and we create, we basically pre-compute every night how many of each ISBN we want. That's kind of a simplified version of it, but we take all of our data up in Snowflake, we run our models off of that data, and then we push back down to production a table essentially of this is the ISBN and this is how many we want. Or we want up to this many.
Yeah, thanks.
Does that answer your question?
Yeah, thank you.
Yeah. And actually SQL Server has a really cool, you can create a linked server between SQL Server and Snowflake, which makes it really easy to pull anything that you've created in production, that you've productionized, any like ML models that you've productionized, you put them into Snowflake, you write them to Snowflake, and then it's really easy pull using like a job in SQL Server to pull that back down. All right, so we're cooking now. So I've just run dbt run. What run is doing is you can see that it's running TB Analytics Trevor Higbee schema inventory. So over here in my profiles, I've said, you know, I want my dev environment to be the schema TB Analytics Trevor Higbee. And I want my prod environment to be just called TB Analytics. And I've said that I want my dev environment to be the default environment. So here when I say dbt run, it just runs against this TB Analytics Trevor Higbee schema. And so if we go back to dbeaver and we refresh, We'll come back to it in just a minute if it doesn't.
You might have to reconnect
Yeah.
since you
to
restarted
validate
it.
and reconnect. I don't want to close that. I just want to. Okay. Well, that's thinking a little bit. We'll let that think. Essentially, it's pushing to the schema that I want it to push. If I were to instead do dbt run t for target or target dev, I'm sorry, cancel it. Target prod. Wow, that's really unfortunate. Okay, so it looks like back there. Let's say we're good there. So again, let's see. So what we did the first time is we just called dbt run. And when you call run, you'll see that it knows to run inventory before it runs order item. It knows that because of this Jinja syntax here and the dependency tree that it generates. And when we said to run it at target prod, it said, okay, fine, I know what prod is. It's called TB Analytics. It's not TB Analytics Trevor Higbee. And so it materialized them to those respective schemas. So we had a question earlier about tests. So another thing I can do is I can just run dbt test. And I've got two tests here, one for inventory, one for order item. The one for inventory just checks to make sure that the ID inventory is unique. And the order item one makes sure that the ID order item is unique. And I can go and I can show you what that looks like in a minute. But essentially it ran those two. It saw that both of them were unique and it passed those tests. Now if I go in here and I cross join and I save, and then I dbt run again, and then I dbt test, we'll see that both those tests fail. Because now I introduced this bad join. So this is super, super helpful because before someone puts up a pull request, I can say, hey, show me all the tests that ran. Or I can pull someone's branch and run the tests myself and see what's going on. So it's really, really useful to make sure that no regressions are being introduced. The way that those tests, there's two types of tests, but this is the most simple one. And the way that that's done is I'm just saying in the inventory table on the column ID inventory, make sure it's unique. And for the order item table on the column ID order item, make sure it's unique. So there's no more code I have to write. I just tell it to be unique and I run dbt test and it runs. So that's pretty phenomenal. The other thing that we want to do is build like build these tables incrementally. So if this table right here, let's say we don't want to drop and recreate it every time. Instead, we just say, look, I want to do an incremental. And if I'm running an incremental, then put this qualifier in here to make sure that I'm just inserting items where the max, where the order item identifier is greater than the max ID order item in this model that I'm working in. So you'll see up here, oh, sorry. when I was targeting dev, it looks like it inserted 572 items. This was for our bad test. But you'll see it now when I save this, because I've told this to be incremental. If I do dbt run, this order item inserted no rows, because no rows have been added to my raw table since I last ran this. But it's essentially just going to run incrementally every time, unless you do a full refresh. I believe that's the syntax. I don't do full refreshes often. But let's take a look at that and see if it works. So with a full refresh, it ignores this incremental up here and just regenerates everything. So you can see how that's really powerful, because if I want to regenerate everything on Saturday nights, then in my CD process, I just make sure that I set that flag and it runs, fully every weekend or every Saturday night or whatever. So that's really nice. The other thing, I think this is the last thing I want to show you, or the last thing I want to show before. I guess there's two things. I've got 2 6s here. Speeding up the development cycle. So I talked about how we don't want to wait around forever for inventory to generate, because it's super huge. You can materialize this to a view very easily. And now if I do dbt run, it's going to see that I want to materialize inventory as a view. And if I wait for that, you see instead of create table, it says create view. And if I open this baby up here and refresh, we've got our view right there. The last thing I wanted to show before we kind of wrap up is logging. So we had this thing when we did it manually, where we were logging run times with these GUIDs, before and after. With dbt, if you look in your dbt project, you can define an on-run start. So every time you run, every time you call a dbt run, it'll run these 2 commands. And every time that you run a model, you have 2 pre-hooks, and it'll run these 2 commands, or sorry, a pre-hook and a post-hook. So on run start, it creates the schema if it doesn't exist, run log, and it creates our run log table as well. And then before every model is run, so before inventory, before order item, it inserts into the run log. And then after every model runs, it inserts into the run log. And you can see that happening here. We haven't really looked at it. It's kind of just happening on the back end. But if we look at the run log and check out the data, you can see that it shows all the runs that we've done. And this is really helpful, because then you can see over time, how long is this model taking? Did we introduce a change that's making it take a lot longer than it used to? As far as like deployment, it's kind of the same as rolling your own. This is just a set of files. So you push it to your server. You do whatever code reviews you want to do. You press when the PR is approved, it gets built, and that built might mean a lot of things, but it basically takes those files and stages them somewhere, and then for your release, for your deployment, you just deploy it out to whatever server it's going to run on, and you have a cron job or something else that calls dbt run on a schedule. So I know a lot of people use Airflow, they use cron. We actually just run it through a scheduled release pipeline in Azure DevOps is what we do. So we have a scheduled release, and it literally, the release itself runs runs dbt. And actually, I think I have in my extra slides here what that looks like. So here's our deploy pipeline. We have a task called dbt run that just runs on the command line. We just say dbt run, and we give it a project directory and a profile directory. And then we take some documentation and copy it to a web server. I guess that's probably the final thing I'll show you is dbt docs generate. And then dbt docs serve. And so in your CI/CD pipeline, you're going to generate the docs, and you'll take those and you'll push them out to a server, which is what we do. And this is what those docs look like. It's a really awesome web page with my schema right here. I can look at inventory. I can add descriptions to all these columns. I can add a description to the inventory table. But I think what's really awesome is that you can have this compiled view of the SQL that actually generated this. And so if someone's wondering, hey, what's that book type? How is it defined again? It's really, really easy to go in here, search for inventory or book type, and say, oh yeah, it's that ID site X 2020. I remember that. I've been talking a lot. Any other questions or comments or thoughts on DBT or kind of what it does, which has kind of been the focus of this demo?
So I'll start with one documentation question. So all of the extra information about what this actually means and things like that is that defined in your DBT model, or is that?
Yeah, it's actually defined here. It's defined in your schema.
Mm-hmm.
So there's a syntax. I don't have it off the top of my head, but under columns, you have like a description, I think. This is, or,
Okay.
like that. So that, this is the ID primary key. I'm not sure that that's the syntax, but it's something along those lines. So it's actually really nice because when you add a field as part of your review process, excuse me, you can make sure that if you add a field or modify a field, that description is also changed. So you can keep your documentation pretty well synchronized.
Okay, and then we got some questions here in the chat. Is there a visualization of the object dependencies generated by DBT?
Yeah, there is. Actually, should have showed you that. So in the documentation, you can click on here, lineage graph. So I'm looking at inventory. And it'll show me my lineage graph. And it'll show me that I'm pulling from a raw table and pushing to a different model. And if I go to the order item table, it gets a little bit more complicated, obviously. And I'm pulling from the inventory model, but also the order item raw table. And these actually get really, really complex. I've got a picture of that as well. In real life, that is our inventory table right down there. And these are all the different dependencies. And it looks crazy, and it is crazy. But imagine how crazy it would be if we were trying to do this without DBT. Or here's the inventory table here, and here are all the other tables that use it downstream. So another thing that the DBT will do is tell you when there's a circular reference. So if inventory is helping to build this table, but then inventory also needs this table to build itself, it'll squawk and it'll tell you, hey, you're doing something wrong here.
Cool. The next question: Do you use exclusively DBT to manage refreshing semantic and aggregate tables in Snowflake?
Refreshing, yes. We use solely DBT. So DBT runs every night. It runs at midnight, and it takes about 4 hours to completely refresh everything. That 4 hours is actually getting pretty long for us. And so we just regenerate everything at this point. We could do two things. We could go from an extra small to a medium, or we could start implementing some of those like incremental strategies or create some views instead of tables and things like that. That's something we definitely need to test. But what's nice is that with the logging that you can implement really easily, you can tell whether what you're doing is having an effect and at what tables it's having an effect.
Okay, and there's another one here. Do you have many DBT jobs or a master DBT job?
Yeah, so there's for us, there's one DBT job that runs everything. I know people run lots of them, and I know that people will even deconstruct the graph here, and they'll copy it into Airflow, and then have Airflow run their DBT models. So there's lots of different ways to kind of schedule stuff, but we've kept it really simple, and we just have one DBT instance that runs once every night.
Okay, then so do you know how you manage dependencies between the DBT jobs then?
I think you'd have to do something. You'd want to keep your contexts really separate. You want to keep those bounded, right? So you don't want to be pulling from. I mean, there's probably some way of doing that, but I would think that you want to keep those pretty separate. You want to keep whatever raw tables you're pulling from and whatever dependencies you are potentially creating, not crossing the streams on those projects.
You never want to cross the streams. It's always a bad thing.
But I guess I will say one thing is that like if you look at this lineage graph, if I'm trying to build order item, I could very well build inventory. I guess if these were both models, right? I could build like this together and this at the same time, right? So you can kind of parallelize the build. You can actually do that super easily with DBT by indicating the number of threads that you want it to run. But if you do that, let's say you say I want to run 3 threads, you'll need 3 Snowflake warehouses for that to be really efficient. But it can parallelize all those the running of all those models.
Cool. That's all of them from the chat. Any other questions out there?
So to wrap up, I just wanted to talk about what's next for ThriftBooks, and to talk about that, I think what would be really interesting to look at is kind of where we've been and where we're going. So this is a chart of published by Snowplow, and no affiliation with Snowflake or anything, of data maturity, kind of like the different stages of data maturity. So you've got data aware, data capable, data adept. As I look at this, a year ago we were here. Some standardized reporting, but data was siloed. Reports living in spreadsheets. No business goals around data. We're wasting time preparing data. Low trust in data. Single source of truth. All of these things were us about a year ago. With all the changes that we've made, we're moving toward a much better state. So joining data from multiple sources, custom models to uncover new insights, single source of truth. We can definitely do more on using this data to drive our core product, ThriftBooks.com. I think we have a lot of work to do on creating a shared data vision as well. That people portion of things is so important. But we're also exploring multi-cloud. I said we're in Azure. We're also looking at AWS. And then there's a lot of ML that we're using as well. And I think part of that is because as soon as we set up Snowflake, our data scientists were super hungry, and they just went in there and were able now to pull the data that they needed to pull. And so they were kind of really our first users of Snowflake before we even had data that was nice and groomed. I think that's it.
Maybe I'll throw out a question just about terms of adoption. I'm trying to think through sort of like how it would work, trying to get like imagine, or maybe turn it into a question. Like, did you guys have like multiple other like analytics teams writing these pipelines, and like how'd you get them to sort of buy into the framework and get the full value out of DBT?
Such a good question. So all of this work was done by me over the course of a year. So one person.
So how did you convince yourself to use? No, I'm just joking.
So, one person, I mean, I've been with the company for a really long time. And so I know where all the bodies are buried. Like I know where all the data is. And so I was a really good candidate for building something like this. But, I think what you're getting at is really the crux of the problem is like on the people side, like organizationally, how do you make this work? From a money perspective, how do you get the money to like go out and buy Snowflake? Because it costs 20, 30, 40, 50, $100,000 to go in on Snowflake. Mode costs tens of thousands of dollars. Fivetran, tens of thousands of dollars. Like you've got to have the money for that. And so being able to convince people that it's going to be worth it, first of all, I think is a big problem. And I've just taken the tack of if I build it, they will come. And so as I've kind of built stuff out, I'll kind of evangelize and say, oh, I see you're working on this problem over here. We've already solved that. And here's how we've solved it. And I'll go, try to help people use Mode and interact with that data. We just hired our first data engineer at the beginning of the month. And she's awesome. She's taking a ton of load off of me. My goal was to, at the beginning of the year, transfer this whole project to somebody else. Then COVID hit and all sorts of stuff. And just recently we were able to hire someone to kind of take it all over. But I think that's the biggest problem I currently have right now. How do we get people to really use this data and to make it like a truly self-serve analytics environment? I think there's lots of good ideas out there. To be honest, I don't know how we're going to solve that. Does that kind of answer your question, or did I just kind of talk around it?
No, that's super helpful. Yeah, I'm in an environment where there's a lot of other analytics engineering teams building like curated tables and just sort of doing their own thing. Some of them are doing it in Alteryx, some of them are doing it in like SQL scripts. And I was just trying to think through like how would you even sort of like get buy-in? And then like it looks super powerful, like especially once you have multiple sort of layers of your data.
Yeah.
Kind of, well, the data layer in those pipelines, being able to like show that dependency graph is like, that's amazing. Or just sort of like the lineage of, I don't think I've seen many tools that can actually like connect the dots like that. So that was pretty cool. So
yeah, and I think one carrot that I have is Snowflake. So our finance team has a query that they run for our weekly like management deck, and it takes them like 4 hours to run. And so they had been complaining about that, and frankly, we complain about it all the time because they used up all the CPU and all the memory on our read-only replica, right? And so we said, oh well, all this data is now in Snowflake. Why don't you try it out? And they were like, yes, finally. Not because we were using dbt and all this other stuff. I mean, they didn't care about any of that. What they cared about is, oh, the really fast data, the really complete data is in Snowflake. And I think we keep showing over and over and over again that when there's problems with data in the organization, we can fix those problems. I'm in a really unique position being the VP of technology. I'm in all sorts of meetings, from board level to executive to design sessions to I drop in on the stand-ups and the grooming and all that type of stuff. And so I can help connect the dots and see where there's a really big need and where I might be able to bring speed and more features to what someone's trying to do. But that's really hard in a big organization. Like we only have like 50 people at corporate. Like we have 800 employees total, but the corporate is actually pretty small. So I imagine you have a bigger, kind of a bigger problem to solve kind of politically,
Yeah, that's an understatement. But yeah, no, that helps, man. It looks powerful though. I think
Yeah.
on the, like, especially the DBT stuff, Snowflake I knew was super powerful. And I think a lot of the people in our environment are like pounding the table for a really fast engine like Snowflake. So I don't know if we have the cash for that, but it's cool to see how fast and how sort of game changing it's been for you guys too. So that's cool. Thanks, man.
Yeah, I'd say our whole technology kind of pipeline stuff without any people, including the front end and Snowflake and Fivetran, DBT obviously is free. It's about $100,000 a year. And does it completely replace like multiple FTEs? Absolutely. But it's hard to get that buy-in, right? It's hard to tell someone, oh, let's spend $100,000 that we weren't planning on spending, you know? But to me, that sounds...
And the conversation of, and then we should probably get off of this other platform we're on in order to use it and not be, you know, double paying or triple paying, whatever it is.
Right, right. And then you've got like the sabotage people who are like, hey, I see this regression on Tuesday morning and I knew Snowflake wasn't gonna work. I knew DBT wasn't gonna work. I knew that it was gonna be just as crappy as everything else, which is why I'm super like OCD about like that pipeline, that CI/CD pipeline, making sure that things are reviewed and tested before we send something out.
I think I heard something really key too, in that you were talking about how you demonstrated some key use cases that were really valuable to people. Mm-hmm. And I've seen that in my organization. I'm also using DBT. Being able to, you know, I didn't have the 100K budget to just go out and spend, so I sort of had to bootstrap this. And being able to show that, right, and pull that off cheaply gave me the leverage to then expand and get more budget for that. So it's not always, you know, if anybody wants to talk after, I kind of have experience of bootstrapping the same journey without a huge budget. So there are cheaper routes to this.
Yeah, the other benefit I have is that I own a budget. Like I have money that I can kind of like play around with, you know what I mean? And so I didn't have to really convince people.
I do want to kind of highlight, hopefully everyone caught it, that, you know, being in meetings with finance and saying, oh, you have a problem, let me come consult with you, help you solve it using the technology and some of the foundation we've already built. Like that is such an important piece, and kind of juggling the technical, get the right tools in and build it, but also the consulting and bringing people into the mix and actually taking the time to meet their needs is a very hard thing to do. So kudos to you, Trevor, for doing it there.
Well, and those same people who are like, I knew you couldn't do it. I knew this was going to fail. This is terrible and our way's better. I just have to be like, totally like I'm still a partner for them. You know what I mean? Like I still just, my interest is in making their lives better. It has to be, or it won't work. If it ends up being like a power struggle, then it's just not gonna work. So I just keep trying to find, how can I help? How can I help? How can I help? I think people will just kind of, you know, start gravitating toward it. But I mean, to be honest, we're getting 10 times the value out of this without even having any use like BI and analytics stuff, because our data scientists are able to build products that are just light years beyond what we've been able to build in the past. So that also gives me like a huge cushion, because if anyone says, oh, this DBT thing isn't working, and it's going to, and it has been for analytics, it is completely working for ML and for AI. It's just like lights out. And those people are people whose language I speak really, really well. You know, I mean, and they report to me. And so I have a lot of control and can get a lot of value out of that.
On the like ML side of things, is kind of the modeling and the exploration happening with Snowflake, and then a need to kind of basically productionize where Snowflake isn't in the mix getting hit every time they're like, say, scoring something, or is it actually getting hit all the time by the production models?
Yeah, it's not getting hit every time. We batch
Okay.
everything. We batch everything. But we're moving toward a model where we don't batch everything. So I think we're signing a contract with Snowplow over the next couple days. And Snowplow is just an event collection engine, like a real-time event collection engine. And we're hoping to use like the events that people have on their on the site, the events people generate on the site, to build like real-time recommendations for people. So that's definitely where we'd like to be moving. Super good question.
All right. Anything else? Any more questions for Trevor?
I love talking about this stuff. I mean, it's just a lot of fun for me. It's interesting. It's exciting. If you want to reach out on LinkedIn, you know, do that, and I'd love to extend the conversation.
Can I ask one more question? Since
Yeah.
I've used most of the pieces of the stack,
Yeah.
what was the thing that was most surprising when trying to do this?
Oh,
Good,
gosh.
bad, whatever it is, because like when you're thinking through ideating how you're gonna, you know, designing, you know, how you're gonna do all this, what was the biggest shocker or learning?
The biggest shocker was Snowflake. We were like blown away. I showed you those timings at the very beginning. It was just like, wow, we've been spending all of our time doing what? How long? Like an hour to do this thing that takes literally 1 minute and 36 seconds on the smallest thing? Like that blew our minds. So that was like one of the, that is the like most awesome surprise. As far as like negative surprises, it took us a lot longer to find a BI analytics tool than we thought. And that's just because I involved a lot of the stakeholders in that decision. And I wanted to make sure that it was going to be adopted. The BI tool is really the front end of all of this stuff to the rest of the business. And I knew I could do all the stuff on the back end really super well, and it would be awesome. But if that front end was clunky or hard to use or whatever else, I needed it to be like a pleasure to work with, both from a data side and from like a UI, like simplicity side. And so that took probably like 6 months of my time, not full time, obviously, but 6 months of calling up, you know, Periscope and calling up Tableau and getting a demo and running people through it and calling up someone else and, you know, running something through it. Because what I didn't want, I mean, we sell used books. We're not like flush with cash. You know, our margins are very thin. And I knew if I was going to spend tens of thousands of dollars on a front end, I probably wasn't going to get another shot at like trying it again. So that was probably one of the bigger surprises, is just how difficult that decision was. All the technical stuff was just like, oh, this leads to this, leads to this, leads to this. I have this problem. Oh, there's this solution. No problem. It's the people, it's the process, it's the buy-in that I think is really the tough part.
So did your like master plan of getting everyone involved keep them from complaining about it all the time once you rolled it out?
But we have a whole lot less complaining. Yeah.
A lot less complaining. That's something.
Yeah,
That's something.
And I wouldn't even say we have complaining now. We just have, I have things that I've promised that haven't like materialized, right? Like for the finance folks, I told them I was going to work with them and like completely transform like the way that they get like data. And that hasn't happened yet because I just haven't had the time. And we've just hired a data engineer and we just went through COVID, and I'm actually trying to still run like a 20-person organization, you know, that's moving really rapidly and needs to make all sorts of changes. And so, so what we get is like, oh yeah, haha, Trevor, like we've heard that before. Like that'll be good when we see it, you know, just normal stuff.
It looks like another question did just pop in here. I have a question about how you manage change management between DBT models and Snowflake used in Snowflake models, I guess, used in mode.
Change management.
So say you've got a schema change, right?
Mhm.
In your DBT stuff, but you've got a bunch of visualizations in mode that depend on that schema.
Oh, yeah. Actually, Mode makes that really easy. You push all of your Mode changes to GitHub, and then you pull the repo and you grep it. It's actually super awesome. In fact, I think I might have put it in my slides here because it's a pretty great feature. Maybe I did, maybe I didn't. But yeah, you just, you can take any of your changes in Mode, and there's a GitHub integration. It just takes all your queries and pushes them to GitHub. And so at interval, I think we just do it manually. Like whenever we think about it or whenever we need it, we go into Mode and we click a button. It pushes everything to master essentially on the repo, and then we just pull master, grep it for whatever change we're making. We actually had that happen yesterday. We had a timestamp field that was labeled as a date, and I wanted to label it as a timestamp. And I knew it was going to break stuff, so we pushed everything to GitHub, pulled it down, searched through the repo for that table and that field, and then changed those, and then re-uploaded it.
I guess another question about Mode, how is that like a server tool that you are hosting yourself on Azure, like on a machine, or is that hosted on their cloud, and do they have like a persistence layer to get speed?
Yeah, it's hosted on their cloud.
Okay.
They have a persistence layer that they call Helix. I don't know what they're using underneath. I don't know what caching technology they're using underneath, but they've branded this thing called Helix, which caches all of the data.
Huh, that's cool.
Which brings up GDPR concerns and brings up CCPA concerns and all type of stuff. Mode also has some really great APIs to allow you to clear those caches. So you can programmatically go in there. So when someone comes in and says, "Hey, I want to delete all my data," we go in and delete it all over the place. And then the last thing we do is we reach out to Mode and say, "Hey, clear the cache on these 3 or 4 models, or these 3 or 4 reports."
Then does it have like a scheduling mechanism to like refresh?
Yeah, it does.
So like if your DBT run from your DevOps job refreshes Snowflake, do you have like another, like something else on the Mode side? Oh, okay.
Yep.
That's cool.
It also, the other really nice thing we liked about it is that, so you pay for the license, you pay for the number of seats, but you can send emails of reports to anybody. They don't need a license. And in a lot of the other tools, you needed a license. And we have, like I said, 50 people in corporate, but like 800 people, or we have like 100 people at corporate, but like 800 people across the whole organization. So if we want to send something out to all the shipping leads, we don't want to pay for a seat, a Mode seat for that. That was actually a really big criteria for us, where a lot of other front-end tools, in order to send an email of a chart to someone, you needed to purchase a seat.
Trevor, you can always be a salesman if you need to. You've made all these tools sound really interesting. So I hope I get a chance to work with most of them at some point in my career. They sound pretty
cool. They're all cool.
Yeah, they have some good stuff to offer. That Mode, I had no idea it did so much. I just kind of bucketed it with everything else, and I kind of like the model of it, even though I can see some cons to it as well in like a larger enterprise.
So with Mode as well, there's a Jupyter Notebook integration. And so, and it's pretty killer. You take any result set that you like write in your query, and you have access to that in a notebook. And then you can like build visualizations through Seaborn or whatever else you're using, D3, and really build like cool stuff. So we like that it didn't like there was really no limit to what we could do there. There's some caveats with those. They don't refresh as easily as the other ones, as the native visualizations. And Mode doesn't have like blow you away visualizations. It has like 8. There's a line, a bar, a pie, those things that you kind of need. But it doesn't do like an awesome job at visualizations. What it does is really rapid, prototyping and building and collaboration and SQL. I think, in fact, I know there's a free version of Mode. And I know that they have a community database as well. So you don't even have to hook up to anything. You can just open up the free version. I think it's free for like 1 or 2 users, and go to the community database and just start playing with it. Pretty phenomenal.
I did want to ask one more, and I'd forgotten about it. In the scripts where you're populate or creating your DBT models or populating them, all of yours were a kind of single query. Can they be, if it's more complicated, can it be more of, a set of statements that would populate the data?
Yeah, so there's kind of 2 ways around that, or there's lots of ways around it, but essentially you can just like create a bunch of CTEs, right? If you need to kind of pre-process the data. What we actually have found is really useful is just take each of those chunks and make them precedents of like the final build. And the reason that's really nice, we used to use like a bunch of CTEs. You used to use like 4 CTEs in your model, and then the very last one would be, joining those all together and materializing it. What we really like about not doing it that way and actually building the models as tables or views in separate kind of SQL files is that you can test each one of those. And you can make sure that there are no duplicates. Duplicates are like the bane of my existence because it's so easy to have a really crappy join. It's so easy to do. And when you do that, because you have so many dependencies, you end up just blowing up the whole thing. So being able to test each of those pieces is really important. And then when something does break or someone does have a question, it's really nice to be able to kind of see the components that go into the thing that's been broken and find the thing that it's not like one massive SQL file. It's a bunch of little SQL files that you've kind of brought together. There's some performance hits there as well, but you don't have to materialize all those tables to or all those like upstream tables. You don't have to materialize them to a table or a view. You can actually materialize them as a CTE. You can do what's called an ephemeral, I think that's what it's called, ephemeral materialization, so that DBT knows that it depends on something, but instead of creating a table or a view for it, it just creates a CTE for it.
That sounds kind of cool. It's
awesome. And you can play around with the performance too, right? So if you're materializing four things that are upstream from the table you're interested in as tables, and they're taking a long time, you can say, oh, actually, in the config, you can say, actually, I want to materialize these as CTEs and see if I get any better performance out of that. And sometimes you will, but you still get all the same benefits of testing and of that kind of modularity.
Cool. Okay. All right. Any other questions? No?
This
All
was
right.
super helpful. Definitely appreciate you taking the time, Trevor.
Yeah, reach out. I'm always interested in connecting and hearing what people are doing and trying to figure out how other people are solving problems. And I just like that space, So if you have, questions or issues or just kind of want to talk through something, find me on LinkedIn and we'll connect.
Yeah, and definitely feel free to jump into any of our discussion meetings as well. So always looking for more people to share experiences on data. So that's what
Yeah.
we're all about in this group. So
Yeah, it's a very good group. Actually, when you were talking about that, the lady from Microsoft is coming next. So like, I want to be there. That sounds kind of cool.
yeah. Cool. Well, thank you again. Thank you, Trevor, for taking some time to educate us about ThriftBooks process and how you went to kind of re-engineered the data platform and explained to us a little bit about DBT. Hopefully, I think we all learned a little bit about both DBT and some of the other technologies as well. So big thank you to you for joining us. I want to thank everybody for coming out tonight and learning with us. And hope everybody stays safe. And we'll see each other in the Slack group and at upcoming meetings.
Awesome. Thanks, everybody.
Yeah,
Thanks
guys.
everybody. Everybody have a wonderful evening.
Right.